All right, welcome back. We are on day 5 of ACT Prep Unit 5, Coordinate Geometry. And today we're going to talk about graphing conic sections. All right, graphing conic sections. Conic sections are the figures formed by the intersection of a cone or cones and a plane. The equation for a circle, an ellipse, a parabola, and a hyperbola each have a standard form. Here's your circle, there's your ellipse, there's your parabola, and there's your hyperbola. Okay? Starting with circles, it says the standard form of the equation for a circle is x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. Most of the time, you're going to have to complete the square to make your equation look like this. So what you do is you put your x squared and your x term together, leave yourself some space, put your y squared and your y term together, leave some space, and put your constant on the other side. And then to complete the square for x, you add half of whatever this is squared, but you got to do it to the other side. And then this will factor into a plus half of b squared plus c plus d over 2 squared, and then this whatever this simplifies down to becomes your radius squared. All right, so it says graph this. Well, I need to make this look like standard form. So as I said before, I'm going to put my x squared and my x together, and I'm going to leave some room. Then I'm going to put my plus y squared minus 10y, leave some room, and I'm going to move this to the other side. So I would subtract it off, which makes it negative on the other side. So now I have to complete the square on x and complete the square on y. To complete the square on x, I'm going to add half of b. So b is 6, half of that squared. Only rule is I have to do it to the other side. To complete the square on y, what color? Blue. I'm going to add half of its b, which is 10 divided by 2 squared, but I have to do it to both sides. Okay, so now once you've done that, you're ready to complete the square. This will factor into x minus 3 squared. And the way you figure that out is the square root of this is x, the square root of this is 3. 6 divided by 2 is 3, squared is 9, the square root of 9 is 3. And that's what I mean by it's always going to turn out to be half of b, which in this case is 3. So to complete the square on y, it's going to be a perfect square. The square root of y squared is y. The sign in the middle is minus. The square root of 5 squared is 5. On the other side, we're going to simplify that out, and we're going to have a negative 25 plus 9 plus 25. Those cancel, and so I end up with x minus 3 squared plus y minus 5 squared equals 9, which makes my h, try to pick a good color here, that would make h3, that would make k5, and that would make r3, because this is r squared, so square root it to get your r. So the center of my circle is at 3 comma 5. So 3, 5, make a dot. And then your radius is 3, so 1, 2, 3 out, 1, 2, 3 up, 1, 2, 3 out, 1, 2, 3 down. Draw your circle, and there you go. Pretty cool. Alright, an ellipse. An ellipse is all points such that the sum of the distances from any point to two fixed points called foci is constant. The standard form of the equation for an ellipse is this one right here. Okay, the couple things that you have to be careful of if you have an ellipse. 1, this has to be a plus, and 2, this side has to be 1. If that's not a plus and the other side isn't a 1, you do not have an ellipse. Okay? Then the next thing you have to look for is which one is bigger. If a squared, if whatever's underneath the x binomial being squared is bigger, then your ellipse will be elongated horizontally. In other words, your major axis will be running horizontal. Okay? If the whatever is underneath the y bino is bigger, okay, then your ellipse will be elongated vertically. In other words, its axis will be a vertical axis. Okay. You can figure out where your ellipse crosses at with these formulas. But I kind of have a way to cheat a little bit. And again, if a squared is a larger denominator, then the major axis is horizontal. If b squared is the larger denominator, then the major axis is vertical. But generally, we switch this, okay? And then the foci are located on the major axis, and all you do is take the square root of a squared minus b squared, and the absolute value, because you don't want a negative. All right, so for an example, all right, they want us to graph this. Well, the first thing I'm going to do is find my center, okay? And if you remember your formula, it's x minus h squared, y minus k squared, and then this is bigger, so this is going to be my a squared, and this is going to be my b squared. So since a squared is bigger, I know that the thing is going to be elongated like that, okay? All right, so actually, this side has to be 1 or it's not an ellipse, but if I minus the 6, then you get 1 on this side, which is what I need. So my center, h is negative 3, k is positive 2, so my center is at negative 3, comma 2. So if I plot that, negative 3, comma 2, we're right there. Okay, now I'm going to find my a squared. So a squared is 36, which makes a equal to 6. B squared is 4, which makes b equal to 2. If you want to do this, you can, and I will, just to be professional here. So to get where your ellipse crosses at, you're going to do h plus a comma k and h minus a comma k. That will be your horizontal ones. And then you're going to do h comma k minus b and h comma k plus b. Alright, so if I plug in my numbers there, my h is negative 3 plus my a is 6 comma my k is 2, and this is going to be negative 3 minus 6, comma 2. So this would be 3, 2, and this would be negative 9, 2. So if I plot those, 3, 2, and negative 9, 2, but what I was going to show you is, if you look, a is 6, and it says that a and b are half the lengths of the axes. So if a is 6, and that's half the length of the axis, all that means I have to do is go 1, 2, 3, 4, 5, 6 this way, and 1, 2, 3, 4, 5, 6 this way. And I get the same points, and I don't have to do all this work. Especially on an ACT, not that they're going to probably ask you to graph one on an ACT, but they might ask you to match graphs, and who wants to do all that to figure out your vertices when all you have to do is count out a both ways from the center. Same way with finding the top 2 points. I can do the math if you want. This is going to be negative 3 comma k minus b, and my b is 2, and h k plus b. So this would give me negative 3 0, and this would give me negative 3 4. So I would have negative 3 0 is right here. Oops. And negative 3, 4 is right here. Or, and like I said, it works, and that's professional, and that's what you should do. But again, in a test type situation, again, keep this in mind. B is half the length of the other axis. So from the center, if I go 2 up and 2 down, I get my 2 points. Connect those 2 points, and there's your ellipse. Now, we could do a better job, and we could get our foci and all this other stuff. And again, that you would want to do that. I wouldn't, again, depending on what the question is asking on the ACT. If they're just trying to make you match the graph, then find your center, find your A and your B, and make sure that the graph that you pick has the correct 6 this way, 6 that way, 2 up, 2 down. But a lot of your questions, they're going to ask you, where are the foci located? So if you have to find the foci for whatever reason, because the problem asks you to, I mean, your foci is kind of what makes an ellipse an ellipse. It's what makes it cool. Your foci, wherever they are, which they will always be a certain distance from your vertices, your major vertices. Okay, there's going to be somewhere inside there. But what's neat about it is that what that means is that first definition where it said that the sum of all the distances from any point to 2 fixed points called foci is constant. That's what the foci are for. Anyway, it's going to be, my foci are going to be located this far, located on the major axis, this many units from the center. So if I take the square root of the absolute value of a squared minus b squared, I get the square root of 32, which can be broken down by 2 is 16, by 2 is 8, by 2 is 4, by 2 is 2. That's a perfect square, 2. That's a perfect square, 2. This can be 4 square roots of 2. Okay? Now, so my foci are going to be starting at, again, we're going sideways, so I'm going to look at the x-coordinate of my foci, of my center, which is -3. So I'm going to take my center, and I'm going to add 4 square roots of 2, and I'm going to take my center, and I'm going to subtract 4 square roots of 2. If you're going to actually graph it, on the test, if it just said where the foci located, this would be your answer, and it would probably be in that form. But if you actually had to graph it, okay, that's a little bit hard to do, and I forgot to type it in the calculator. Square root of 32 is 5 something or other. Alright, so if I do -3 plus 5 and a little bit, it's a little bit after 2. Oops. It's a little bit after 2, so that would be my foci. And if I did -3 minus 5 something, that'd be -8 something. So that'd be somewhere around in here. So the foci in this case are really close to your vertices. Okay? Alright, your parabola. A parabola, there are 2 standard forms for a parabola. You either have y minus k equals a parentheses x minus h squared. And there's lots of different forms for this, guys. Lots of different forms. But what they're calling standard form is what I call vertex form. Okay, you have y minus k equals a parentheses x minus h squared. If the x is the variable that's getting squared, then I promise your parabola will be vertical. It'll either open up or it'll open down. Okay? If the y quantity is the one being squared, you'll still have a parabola, but it'll be horizontal and it'll face sideways. Either way, your vertex is at h comma k. So to graph a parabola, you're going to write your equation in standard form, plot your vertex, which is h comma k, then choose 2 x values close to the vertex, plug them in, find the y's, plot the points, and connect to the vertex. So it says graph this equation. Well, first of all, I need it to look like in this case, x is squared, I can tell, so I need it to look like the y minus k equals a parentheses x minus h squared. So the first thing I notice is I'm going to move this constant. And again, I was tempted to, and you can go this route. You could have combined 80 and 2 and then tried to factor this and go that way. But they set it up so that it's easy to make it look like this. So if I minus the 2, I have y minus 2. And on this side, since that's gone now, all of these have a 5 in common. So I'm going to GCF a 5 out, which would leave x squared minus 8x plus 16. I just divided the 5 out of all of these. Okay, we're getting closer, but I need to make this trinomial, a perfect square, and it is. Like I said, they set it up where this would work out very nicely. This is a perfect square, so it's going to be the square root of x squared is x, the sign in the middle is minus, and the square root of 16 is 4. So now it looks like this, which means my h is 4, My k is 2. So my vertex is at 4, 2. Now, I know that my axis of symmetry is right through the vertex, always. And this one's vertical because x is being squared. So I know this thing, and a is positive, so I know this thing is going to open up. But to get a good idea of how wide this is, I need to pick another point. So again, since the vertex was at 4, 2, I'm going to pick 3 or 5. You can get farther away, but quadratics get big really fast on the sides, so you want to stay close to your vertex. So I'm going to see what happens if I make x equals 3. What's y? Well, if I make x equal 3, I have y minus 2 equals 5 parentheses 3 minus 4 squared. That's y minus 2 equals 5 times negative 1 squared. That's y minus 2 equals negative 1 squared is 1 times 5 is 5. Add 2, and I get y equals 7. So this ordered pair would be 3, 7. So I go to 3, 1, 2, 3, 4, 5, 6, 7. And you could then pick y equal 5 and do the same thing, but the nice thing about parabolas is there's a reflection across that axis of symmetry. So since this point is 1 dot away from the axis, then I know there's one dot away on the other side. So if I connect, I have a pretty thin parabola, and there she is. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 2. So it says, given the equation of a circle, what is the sum? So they're telling me to add the x coordinate of the center, the y coordinate of the center, and the radius. Well, for my equation, there's h, there's k, and there's r squared. So h is 3, k is negative 5, and r is 4. Okay, the vertex would be 3, negative 5. So it wants me to add the x coordinate of the center, the y coordinate of the center, and the radius. And you add all those up, and you get 2. 3 plus a negative 5 would be negative 2, plus 4 would be 2. Alright, try this one, hit pause, come back when you're ready. And hopefully you got G. What are the coordinates of the foci of an ellipse with this equation? Well, first of all, I need a center, which h is negative 1, k is 2, so my center's at negative 1, 2. Okay? And I kind of like to draw myself a little sketch, negative 1, 2. Okay? This is a squared, it's under the x squared, so my ellipse is going to go long ways. Alright, so my foci, remember, are located at square root of the absolute value of a squared minus b squared. So my foci is going to be the square root of the absolute value of 9 minus 4. So there's a squared, and there's b squared. And that's going to give me the square root of 5. Okay, so to get the location of my vertices, that's the length of my foci, but mine is starting at negative 2. So I'm going to have, negative 1. Wow, I can graph. Negative 1. So I'm going to start at negative 1, and then I need to go square root of 5 units this way, and I need to go the square root of 5 this way. So I have negative 1 plus the square root of 5, comma 2, because we're still at a height of 2. And I have negative 1 minus the square root of 5, comma 2. And those would be my foci. Okay, try this one, hit pause, come back when you're ready. I notice on this, I've already got the y minus k, so I don't want to mess with that. On this side, I somehow need it to be a perfect square. So GCF that 2 out. Divide by 2 by 2 by 2. I'd get x squared minus 6x plus 9. This is a perfect square, so y minus 5 equals 2. The square root of x squared is x. The sign in the middle is minus. The square root of 9 is 3. Okay, that makes h equal 3 and k equal 5. So my vertex is hk, which is 3, 5. Okay, so now let's do some practice. Okay, it says find the center and the radius of a circle represented by this equation. Well, this tells me that h is negative 2, that k is positive 3, and that r is 4, because this is r squared. So the center is at hk, and my radius, again, is the square root of that. Okay, 2 says complete the square for this equation. Well, again, when you complete the square, you leave yourself some room. Make sure a is 1 first. And you add half of b squared to both sides. Okay, so then this gives me x squared. Well, I could actually just factor it right now. This is going to be a perfect square then. The square root of x squared is x. The sign in the middle is plus. The square root of 2 squared is 2. And on this side, 4 divided by 2 is 2. Squared is 4. 0 plus 4 is 4. There we go. Okay, 3, write the equation for this circle in standard form. Again, we're going to have to complete the square to get everything in standard form. So I have my x squared and my x, leave some room, plus my y squared plus the y, leave some room, equals, move your constant over, and that would make it positive 26. Then I'm going to add half of b squared, so add half of 10 squared, but I have to do it to both sides. That'll complete the square on x. To complete the square on y, I have to add half of his b squared, so 14 over 2 squared, but I have to do it to both sides. Now I can factor the x's. That's going to be a perfect square. Square root of x squared is x. Sign in the middle is minus. Square root of 5 squared is 5. Okay, complete the square on y. That's going to give me a perfect square. The square root of y squared is y. The sign in the middle is plus, and the square root of 7 squared is 7. Simplify the other side. I get 26 plus 10 divided by 2 is 5. Squared is 25. Oh, I get 26 there, 25 there. 14 divided by 2 is 7. Squared is 49. So I get x minus 5 squared plus y plus 7 squared equals 100 if you add all that up. So my center is going to be at 5, negative 7, and my radius is going to be 10. Okay? 4 wants me to graph the circle represented by that equation. So first I'm going to have to get it in standard form. So I have x squared minus 4x, leave some room, plus y squared plus 12y, leave some room, equals negative 24 if I move that over. Alright, I'm going to add half of b squared here, so half of 4 squared, but I got to do it to both sides. To complete the square on y, I'm going to add half of 12, because that's his b squared, but I got to do it to both sides. Okay, I'm ready to factor the x's. That's going to be a perfect square. Square root of x squared is x. Sign in the middle is minus. 4 divided by 2 is 2. Squared is 4. Square root of 4 is 2. Complete the square on y. Square root of y squared is y. Sign in the middle is plus. The square root of 12 over 6 squared would be 2. Okay, and then on the other side, I'm going to PEMDAS it. Type it in the calculator, whatever you want to do, and I get 16. Okay, so therefore that makes my, that makes my center at 2. Oh crap, 12 divided by 2 is 6 squared, and the square root of that is 6. Sorry, so my center is 2, negative 6, and my radius, since this is radius squared, would be 4. Alright, the equation of this ellipse is this, and check to make sure that it is. That's a plus, yes. That's a 1, yes. Now, since the bigger square is under the y, that tells me that my my ellipse is going to do this. Okay, so there's a squared, and there's b squared, there's h, and there's k. So it says, what is the center of my ellipse? Well, it's still hk, which is going to be 2, negative 3. Is the major axis horizontal or vertical? Well, like we said, since a squared is under the y, since the bigger square is under the y term, it's going to be vertical. 7, what are the coordinates of the foci of that ellipse? Alright, well, my coordinates are going to be the square root of the absolute value of a squared minus b squared, which is going to be the square root of absolute value of 9 minus 4, which again is going to be the square root of 5. But to get the coordinates, I got to figure out, well, my center is at 2, negative 3. It's going to be long ways. So this is going to be my, to get the coordinates, this is going to be my, I've got to do this to the y. So I'm going to keep the x the same. I don't want to move from there, so I'm going to keep the x the same. But my y coordinate, which is negative 3, is going to change by the square root of 5. Once by adding it, and once by subtracting it. Okay, whatever that negative 3 plus the square root of 5 is, square root of 5 is, I don't know, 2 something. So around negative 1 something. And around negative 5 something or other, close to that. Those would be my foci. So my vertices would be farther out, and it would be something like that. Okay? Here's another ellipse. I can tell because this is positive and this is 1. This time my bigger square is under the x terms, so that's my a squared, and 16 is my b squared. And it says, at what points does this ellipse cross the major and the minor axes? Well, if you remember, where it crosses is at h plus a, comma k, h minus a, comma k, h, comma, k plus b, and h, comma, k minus b. Whatever order you go in is fine. Alright, my h is negative 1, my k is positive 2, a would be 5, b would be 4. If a squared is 25, then the square root of that would be a, which is just 5. So I'm going to have my h, change colors here, my h, which is negative 1, plus 5, comma, my k is 2, negative 1 minus 5, minus 5, comma 2. Over here, I'm going to have negative 1, comma, 2 plus 4, and negative 1, comma, 2 minus 4. This is going to give me 4, 2. This is going to give me negative 6, 2. This is going to give me negative 1, 6. And this is going to give me negative 1, negative 2. So if I plotted my center, negative 1, 2, my vertices are at 4, 2, negative 6, 2, and again, look at A. A was 5. Well, all I had to do was go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, my other two are negative 1, 6. So right above the center, negative 1, negative 2, right below the center, and again, B is 4. 1, 2, 3, 4 up, 1, 2, 3, 4 down. That will be my ellipse. Okay? What are the coordinates of the foci? My foci is going to be the square root of the absolute value of a squared minus b squared, which gives me the square root of 9, which gives me a foci length of 3. Your foci are going to go out from your center, and since this is a horizontal ellipse, they're going to go out horizontally from the center. So I'm going to have, my center is at negative 1, 2, so my foci is going to be at negative 1 plus 3, comma 2, and negative 1 minus 3, comma 2. Because I'm starting here at negative 1 and I'm going 3 units this way. 1, 2, 3, and 3 units this way. 1, 2, 3. And let's see if we're right. Negative 1 plus 3 would be 2, comma 2. Yep. Negative 1 minus 3 would be negative 4, comma 2. Yep. Those are where my foci are located. Okay, give me just a second. I will be right back. Alright, I'm back. Okay, so, got it, right? Alright, so this now that wants to know, is each parabola vertical or horizontal? Well, if x is squared, it's going to open up or down, which means vertical. I'll put an A there. This is when the x is squared. If y is squared, they'll open sideways, and that's when it's horizontal. So since the x term is being squared, vertical. Since the y term is being squared, horizontal. Since y is being squared, horizontal. Since x is being squared, vertical. Okay? The equation of the parabola is y equals 4 plus yada yada yada. What is the standard equation of the parabola? Again, you might be tempted to combine 4 and 54, which I was at first, but then I realized they set it up really nicely where you subtract this one off, that's your k, and then this side you want to make into a perfect square. Well, you don't, to complete the square, x, a, whatever's touching x squared, has to be 1. So I've got to factor out a 6 whether I want to or not. So factoring out a 6, I get x squared minus 6x plus 9. And sure enough, now that's perfect. Which, again, they're setting these up where they come out like this on purpose. It doesn't happen very often in the real world, but whatever. So I'm going to have y minus 4 equals 6, and this is going to be a perfect square. The square root of x squared is x. The sign in the middle is minus. The square root of 9 is 3. And there we are in standard form. Okay? So the vertex, then, here's your h, here's your k. So my h is positive 3, my k is positive 4, so my vertex is at 3, comma 4. Okay? Alright, now we're going to talk about hyperbolas. A hyperbola is a set of all points in the plane for which the difference between the distances to two fixed points, called foci, is constant. Remember, for an ellipse, it was the sum between the distances to two fixed points was constant. And so the only difference pretty much between a hyperbola, as far as the equation goes, between a hyperbola and an ellipse, is ellipse has to be the plus, and the hyperbola has to be a minus, and the other side has to be a 1. Okay, so a general equation for the hyperbola centered at hk, if the biggest, again, if it's the x quantities that comes first, in other words, in front of the minus, then your axis is going to be horizontal, which means your parabola will look like this. Your two little, basically halves of ellipses, will point at each other vertically, okay? But the transverse axis is horizontal. Oh, so that's not this one. This transverse axis is vertical, so that's when a squared is underneath. In other words, when the y squared is first. All right, if the transverse axis is horizontal, the equation of the axis is y equals k. If the transverse axis is vertical, then the equation of the axis is x equals h. The vertices are a units from the center along the transverse axis. The distance along the transverse axis from the center to a focus is c, and that you can get by taking a squared plus b squared equals c squared. Okay, then you also have these asymptotes that are approached by the hyperbola. And these are your equations to get your asymptotes, these dotted lines. Okay. Now, I kind of have, my notes I kind of liked a little bit better than their notes. So I put my notes on here, and I'm going to use my notes. It says the same stuff, I think just a little more succinctly, and it puts everything in the same page. Okay. Alright, so it says determine the vertices of the hyperbola having the equation. Alright, well your vertices, that's what they're asking for this one, because, okay, see how it's the y's subtracting the x's? So you've got to make sure you're in the right formula. When the y's come first, your vertices are h comma k plus or minus a. Whereas if it's the other way, if the x's are subtracting the y's, then your vertices are h plus or minus a comma k. Okay? When it's the x's subtracting the y's, your hyperbolas face each other sideways. When it's the y's subtracting the x's, then your hyperbolas face each other vertically. Okay, so because the y's are subtracting the x's, then I know that I am looking at, hold on just a second, when the y's subtract the x's, we know we're looking at something like this, okay, up and down from each other. So this is what I expect to see. And I'm sorry, I'm doing too much. All they want is the vertices. So I've got to identify h, k, and a to answer this question. Well, h is always with x, and k is always with y. So my h is positive 1. My k is negative 3. Okay, this is a squared is 36, so a has to be 6. So to get my vertices, I have h comma k plus a and h comma k minus a. That's going to give me 1 comma negative 3 plus 6 and 1 comma negative 3 minus 6, which gives me 1 comma 3 and 1 comma negative 9. Okay? And again, that's all they asked for. I want to, explain more, but that's all they asked for. So we've got the vertices. Okay, this one wants us to determine the foci of the hyperbola having this equation. I look for my foci, and again, it's the x's minus the y's, so we've got to be in this formula box. And the foci is h plus or minus c comma k. Well, I need h, k, and c. I got h, that's negative 3. I got k, that's positive 2. What the heck is c? Oh yeah, that's why they gave me the Pythagorean relation between everything. So I can get c by doing c squared equals a squared, which is 8, plus b squared, which is 16. So that gives me c squared equals 24, and c equals the square root of 24. Which if I break that down, by 2 is 12, by 2 is 6, by 2 is 3, I get 2 square roots of 6. Okay, so 2 square roots of 6. So my foci are going to be at h plus c comma k and h minus c comma k. So if I set this up, I'm going to have negative 3 plus 2 square roots of 6 comma 2 and negative 3 minus 2 square roots of 6 comma 2. And again, if they wanted if I was graphing, I wouldn't want radicals. I'd change those into decimals so that I could plot it better, but that's... And oh, by the way, the book, when I checked my answer in the book says negative 3 plus the square root of 24 comma 2 and negative 3 minus the square root of 24 comma 2. And so they didn't break this down, which makes no sense to me because half the time they do and half the time they don't. So how are you supposed to know? Well, I guess by looking at the answers. Okay? Just beware, if you don't see your answer, back up and see what it was before you simplified it because they might have left it that way. All right, let's graph one of these bad boys. Okay, so what I like to do first, and everybody has their own little deal about how they graph hyperbolas. All right, this is great. When you have no parentheses around your squares, that means your h and your k are 0, which means your center is at 0, 0, which is nice. Okay, so I like to do my center first. The next thing I like to do is I like to get my asymptotes. Okay, so I do my asymptotes next, which again, when your vertex is at the center, to get your asymptotes, you take y equals plus or minus b over a times x. Well, a squared is 25, which makes a 5. B squared is 9, which makes b 9. So my equations for my asymptotes are going to be y equals plus or minus 9 over 5 hold on just a second. 3. What am I doing? B is 3. Okay, so 3 over 5 x. And that's plus 0 because basically what you do is you do your slope from your center. Your asymptotes have to pass through your center. They have to. So from the center, basically all I really need is that slope. So I'm going to go up 3, 1, 2, 3 over 5, 2, 3, 4, 5. Make a dotted line. And from the center, I'm going to go down 3 over 5. Make a dotted line. Okay, so there's my asymptotes. That's what I like to do second. The next thing I like to do is find my vertices. And again, guys, this is just the order I like. There's nothing that says you have to do things in this order. But my vertices are at plus or minus a comma 0. Again, because my center is at 0, 0. So my vertices are going to be at plus or minus 5 comma 0. So I'm going to have one over here at 5 and one at negative 5. There's my vertices. Now, to do foci and all of that stuff, again, it kind of depends on what the ACT is going to ask you to do. They might ask you for the coordinates, but as far as graphing, they're not. I can't see them expecting you to put the foci on the graph. There's just not time. But what you do, I mean, you should have your foci, and I'll get them for you in a second. But you have enough information right now to graph, because if this is the vertice of this hyperbola, half of the hyperbola, your hyperbola runs asymptotic to the asymptotes. So all you got to do is pass through the vertice and make your hyperbola run asymptotic to those red dotted lines. And there's pretty much your graph. Okay, but if they ask you to find and to graph the foci, then you have to find the foci. And my foci here are going to be plus or minus c comma 0. Well, I need c in order to get my foci. And the Pythagorean relation says that c squared equals a squared plus b squared. So c squared equals 34. So c equals the square root of 34. So my foci are going to be at plus or minus the square root of 34 comma 0, which that's 5 something. It's a little bit more than 5. So it's going to be plus or minus 5 and a little bit, and negative 5 and a little bit. So again, your foci are really close to your vertices in this case. And your hyperbolas will always hug, I call it hugging, will always hug your foci. In other words, your foci have to be on the inside of your curves. Okay? Alright, so we want to do this one. This one's a parabola, so we need a vertex, which is h comma k. My h is going to be 2, my k is going to be negative 3, so my vertex is going to be at 2, negative 3. So I plot that. And then I'm going to pick some x's close, one on either side. They want you to do both, but if you get one, you can just reflect it over, and then you have the other one. So I'm going to make x1 and plug it in. So y plus 3 equals 2 parentheses 1 minus 2 squared. 1 minus 2 is negative 1, squared is positive 1, times 2 is 2. Minus 3, I get y equals negative 1. So at 1, negative 1, there's a dot. And remember, your axis goes through your vertex, and I can just now reflect. Since this is one dot away from the axis, I know there's one dot away on the other side. Connect. And there you go. Okay, so if they want me to graph this parabola, this one has a y squared. So this one's going to be sideways. Alright, well, your h is 2. Your k is negative 1. So my vertex is at 2, negative 1. Now I know this thing is going to go this way. So what I'm going to do is I'm going to pick a different y. So I'm going to pick when y is 0. So if I make y 0, I get x minus 2 equals 3 times 0 plus 1 squared. 0 plus 1 is 1, squared is 1, times 3 is 3, so I have x minus 2 equals 3, add 2, and I get x equals 5. So this ordered pair would be 5, 0, which is right here. And again, this will be my axis now going sideways. So since this is 1 point above the axis, then I know there's one reflected right on the other side. Connect the dots, and there's your sideways parabola. Okay? Graph the circle represented by this equation. Well, there's my h is negative 5, my k is positive 3, my radius is 3 because r squared is 9. So my my center is at negative 5, 3. Negative 5, 1, 2, 3. And my radius equals 3 says go out 3 in all directions. Out, up, out, down. Connect, and there's my circle. Okay, graph the ellipse represented by this equation. Again, I'm going to do this a little short way now. Alright, I know that h is negative 1. I know that k is negative 6. I know that a squared is 16, which means a is 4. I know b squared is 4, which means b is 2. Okay, so I have my center, my brain's freezing up, is at hk, so negative 1, negative 6. Okay, it's the bigger square is under x, so this thing is going to open, or not open, but be a sideways or horizontal ellipse. Alright, now watch, guys. You got to get your other points. To graph, you need the other points where it intersects. Okay, well, you can do all the math if you want to. H plus a comma k, h minus a comma k, h comma k plus b, h comma k minus b. You can do all that if you want to. But guys, you know that a is 4. So I'm going to go out 1, 2, 3, 4 to the right and 1, 2, 3, 4 to the left. And since b is 2, I'm going to go from the center, I'm going to go up 2 and down 2. And that's going to be my ellipse. Okay, and sure enough, if I plug it in, negative 1 plus 4 comma negative 6, that's 3, negative 6. Oh, look, there's 3, negative 6 right there. Okay, if I do this one, I have negative 1 minus 4 comma k, which is negative 5k. but I know k. K is negative 6, sorry. And sure enough, negative 5, negative 6, there's my other vertices. And guess what's going to happen when I do this? I'm going to get that one, and I'm going to get that one. Okay? So again, do the math if you want to, but this is just going to be this way from the center, and this is going to be above and below the center. Okay, so if we graph this hyperbola having the equation, again, no parentheses means my center, h is 0 and k is 0, which means my center is at 0, 0. Okay, again, for me, I like getting my asymptotes next. Okay, so for my asymptotes, it says y equals plus or minus a, which would be 2, because if a squared is 4, then a is 2. And if b squared is 16, then b is 4. So I have plus or minus a over b, which is 2 over 4 x, which is the same thing as plus or minus 1/2 x. So my asymptotes are going to pass through the origin, and it's going to go up 1 over 2 and down 1 over 2. Alright, so then I need to get some vertices. To get my vertices, I take 0 plus or minus a. So mine's going to be 0, positive 2, and 0, negative 2. 0, 2, 0, negative 2. Okay. Oh, I guess we should have talked about this. Thing is going to open, since y squared is subtracting the x squared, these hyperbolas are going to be vertical to each other, up and down. Yeah. Okay, so I've got my vertices. Alright, and then again, you're just graphing. It doesn't say it has to have foci and all of that. These are just going to run asymptotic to the asymptotes. Okay. Alright, so graph the hyperbola having this equation. Alright, so I'm going to have my h is 1, k is 2, a squared is 25, b squared is 36. That makes a 5 and b 6. That gives me a center at hk for 1, 2. Okay, and then I can find, for me, I like finding my asymptotes next. So to get my asymptotes, there's my equation. It's y equals plus or minus b over a times x minus h plus k. So I would have y equals plus or minus 6 over 5 x minus 1 plus k, which is 2. Okay, well, you can read all that if you want to, but guys, I promise you, your asymptotes have to pass through your center, so all you really need to know is the slope. If you've got 1 point on a line and a slope, you can make any line you want. So from my vertex, or my center, sorry, I'm going to go up 6, 1, 2, 3, 4, 5, 6, and over 5. 1, 2, 3, 4, 5. There's one asymptote through the center. And then from the center, I'm going to go down 6 over 5. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. There's my other asymptote. Alright, we've got x minus h squared. Since the x's are subtracting the y's, my parabolas are going to be sideways. And all I need now are the vertices. So to get my vertices, I use that formula, which says h plus or minus a, comma, k. So that's going to give me 1 plus or minus 5, comma, 6. 1 plus 5 is 6, comma 6. 1 minus 5 is negative 4, comma 6. Oh my goodness. K is not 6. K is 2. My bad. Okay, so 6, 2, negative 4, 2. And again, I should find my foci. It makes a more accurate graph, but I know that I've got to run asymptotic to the asymptotes and pass through that vertex. I mean, vertex. Okay. Alright, try this one. Hit pause. Come back when you're ready. Hopefully you got D. They want the center of this circle. Well, I've got to get it looking like a circle first. So I'm going to split my X group from my leave some room, then my Y group, leave some room, and then my constant moves to the other side, which changes the sign. So now I've got to complete the square on X, which means I'm going to add half of 6 squared, but I got to do it to both sides. And to complete the square on Y, I'm going to add half of 2 squared to both sides. Okay, so then I have, sorry, I was thinking. So this is a perfect square. Square root of x squared is x. Sign in the middle is minus. Square root of 3 squared is 3. Complete the square on y, I have y, sign in the middle is plus, square root of 2 divided by 2 is 1, so y plus 1 squared equals, this is going to be negative 9, plus this is 3 squared is 9, plus this is 1 squared, 1. Those cancel, and I have x minus 3 squared plus y plus 1 squared equals 1. Okay, which means my center is at 3, negative 1. Okay, try this one. Hit pause, come back when you're ready. Hopefully you got y equal negative 7. Okay, the reason I know that is h is 4, k is negative 7. So my center is at 4, negative 7. Okay, the x's are first, or 49 is bigger than 36, so a squared is under the x squared. So that's going to be my major axis. This thing's going to run sideways. And the equation of that line, that major axis, would be, it's going through negative 7 horizontally. So that makes it y equals negative 7. Okay, try this one. Hit pause. Come back when you're ready. Hopefully you got C. What is the sum of the x-coordinate and y-coordinate of the vertex of the parabola with this equation? Well, first of all, I've got to get my vertex. There's lots of ways you could do this. They want you to complete the square. And I spent a lot of time teaching you that. There's an easier way. If you just want the vertex if you just want the vertex. Your vertex is h comma k. There are formulas that allow you to find h and k other than from completing the square. But it's more formulas to remember it. So I don't know if you want to try and remember both, but I'll show it to you anyway. You can find h by taking negative b divided by 2a. You can find k by doing c minus ah squared. Okay, that will find you your h and k, which finds you your vertex. So h equals a negative, my b is negative 8 over 2 times my a is 1. That's 8 divided by 2, which is 4. My k is my c, which is 10, minus my a is 1, times h, which I got was 4 squared. So that gives me 10 minus 16, and that gives me negative 6. So my vertex is 4, negative 6, and the sum of them would be 4 plus a negative 6, which gives me negative 2. Okay, which is the equation of an ellipse? Well, if I check the first one, I'm going to have, the only way it's an ellipse is this side has to be 1, for one thing. So the first thing I'm going to do is divide by 16. That just gives me x squared over 2 minus y squared over 2 equals 1. So I got 1 over there, but you see how these are matching? It means you have a circle. Okay, g, I have x minus 3 squared plus y plus 7 squared equals 3. Alright, and on this one, I divide by 3, divide by 3, divide by 3. Again, I get 1 over here, but do you see how these match? That means, again, you have a circle. Okay? The third one then, if I have 4x squared plus 9y squared equals 36. Okay, if I divide through by 36, because the only way it's an ellipse is if I can get 1 on the other side, that reduces down to x squared over 9 plus y squared over 4 equals 1. That would be your ellipse. Okay? Because the denominators are different, which makes them not the same, which makes it not a circle. It makes it elongated. Okay? So I'm going to tell you to hit pause. Alright, do this one. Hit pause. Come back when you're ready. Alright, I got to figure out what kind of graph this is. Well, if I can get the equation in standard form, I can recognize it. So what I'm going to do is I'm going to, they've grouped the y's, they've grouped the x's. So I'm going to GCF a 4 out of this guy. And that would give me y squared plus 2y. Leave some room. Minus, I'm going to take out a 9. That's going to leave us x squared minus 2x. Leave some room equals 41. So now on the inside, I'm going to have to add half of b squared. So I'm going to add half of 2 squared. Now on the other side, which is 1. 2 divided by 2 is 1, squared is 1. On the other side, I'm not just adding 1, I'm adding 4 times 1. Does that make sense? Okay, I divided that 4 out. If I ever got back around to putting it back through, that's not going to be 1 squared, that's going to be 4. Okay, so you've got to, whatever I do to this side, you've got to do to that side. Okay, same with over here on the y's. I'm going to add half of b squared. On the other side, I have to add 9 times that. Okay. Alright, so now we're ready to simplify. This is going to be 4 in a perfect square. Square root of y squared is y. Sign in the middle is plus. Square root of 1 squared is 1. Minus 9. This is going to be a perfect square. X minus 1 equals 41 plus 4 41 plus 4 is 45. This should be minus. Sorry, because this one's, yeah, negative 9 times 1. So I got to do a negative 9 times 1 over here. Sorry. So 41 plus 4 minus 9. And I get 36 over here. So now, to see what it is, it's got to either be a circle, an ellipse, or a parabola, obviously. Well, if it's an ellipse or a parabola, 1 has to be over here. So if I divide by 36, by 36, by 36, I get y plus 1 squared over 9. Can't read that. Y plus 1 squared over 9, because 4 goes into 36 9 times, minus x minus 1 squared over 4, because 9 goes into 36 4 times, equals 1. Well, if this is a minus and you get 1 and these are different, then that means you have an hyperbola, and the only hyperbola in the bunch is D. And what is the center of the hyperbola with this equation? Again, easiest question ever. If there's no parentheses, your center is at 0, 0. Alright, that will do it for conic sections. And I will see you tomorrow for day something, 6? Day 6. See you next time.